All right. So today or tonight, you should be watching these videos and working through these problems. We've done multiplication and division. As you can hear, there's an
Mr.
announcement.
Ashley, Mr. Sutton, and Dr. Price, you can please report to the media center at this time. Mr. Ashley, Mr. Sutton, and Dr. Price. Thank you.
Okay. So what we're trying to do here is solve, is do the same thing we did earlier today. But the problem is we've got these fractions in this problem. So what we have to do is get an LCD, a least common denominator, and multiply this out. Now make sure you copy down these notes so that you get credit for it when you come into class tomorrow and I come and I check, okay? So the LCD, or the least common denominator, remember it's whatever the smallest number that both 5 and 4 can divide into. So for instance, in this case, the least common denominator would be 20, because 20 divided by 5 is 4. 20 divided by 4 is 5. If you can't think of the least common denominator, you can always just multiply these two things together and you'll be able to get a common denominator. It will still work. The problem is the numbers will be bigger. Okay? So what I'm going to do is multiply the top and the bottom of this weird thing, this fractional fraction, or a division with fractions in it, by 20. So when I do that, I've got to multiply each piece by 20. So 20 times 2 is 40. 20 times 3 is 60. 20 times 5 is 100. 20 times 1 is 20. Now here's what should happen to these. Now there's other ways to do this, but it connects to what we're doing. So we're going to keep it this way. The reason I do this, those should get rid of the fractions. So I should end up with 40 plus whatever 60 divided by 5 is, which is 12 here. 100 plus 20 divided by 4, that's 5. So I get 52 over 105. And that's my answer. Now, because there weren't variables, there are quicker ways to do that. Okay? But I want you to see the process. Find the least common denominator, multiply it to your numerator and denominator, okay? Or least common factor. Maybe we should say least common factor. Multiply it to your numerator and denominator, okay? And then you should be able to solve from there. So number 2 is a little bit tricky, okay? Number 2, the LCD is actually, or the LCF is not as tough. The only thing you got going is y here. So again, you could do y times y and multiply by y squared. It's just going to be more work. But that will always work if you multiply the denominators of the two things together. But it's easier just to say, well, y is what we need here. So I'm going to multiply the top and the bottom, the numerator and denominator, by y. So y times x is xy plus xy over y. On the bottom, y times 1 is y. Y times 1 is y. But what should happen is my fractions go away. So I get xy plus x, because the y's here reduce out, over y plus 1. Now, when you get here, you can't just say, okay, I'm done. You have to look at this and see, okay, so what, like we did previously, earlier or earlier today, what can I take out of this? So I can take an x out of both of these terms, and I'm left with y plus 1. Well, I also have the term y plus 1 in the denominator. So those whole terms reduce out, and I'm left with x. So the answer to this question is x. Make sure you ask questions tomorrow if you're not following what I'm doing. I'll be glad to help you, okay? Or pause it and look at it. So here, I've got 2z and 4z. I'm going to look at the numbers first, 2 and 4. The smallest number that both 2 and 4 can divide into is 4. 4 divided by 2 is 2. 4 divided by 4 is 1. The whole, you would get a whole output. Z and Z, okay, would be what they have in common. So I'm going to multiply the numerator and the denominator by 4z. Now, if you had done 2 times 4, you would have gotten 8z, by the way, as a factor. That would work. okay? But 4z is the least, so it'll be the quickest. It'll keep the numbers as small as possible. So 4 times 1, that's 4z. 4 times 1, that's 4z over 2z. In the denominator, 4z squared minus 4z over 4z. Now what should happen is my fractions should go away. So 4z divided by 2z, the z's go away. I'm left with 2. 4z squared, ooh, this is going to be a tricky one, minus 1. Okay? Actually, no, it won't, because that's as far as you can go. You can factor this denominator. So if anybody wants to try it, go for it. It would be 2z. Well, I'll let you figure it. And you can ask me in class if you want to know. But that's as far as I can go. Okay? All right. Number 4. So when we look at this, you're like, man, Mr. Duncan, there's a lot going on. This is too difficult. It's not. You're okay. So when I look at these, you've got a and a squared. Well, a squared can be divided by a and by a squared. So all I can do, if I've got variables like this, what's the variable that's, if it's all the same variable, what's the variable to the highest power? In this case is a squared. So a squared would be my least common factor. So I would multiply a squared to everything. So a squared plus a squared over a plus 2a squared over a squared. All I did was multiply a squared times all those things in the numerator. And then on the bottom, 2a squared plus 5a squared over a plus 2a squared over a squared. So I get a squared plus a plus 2. Because an a goes away here, both a's go away there. In the denominator, 2a squared, and a goes away, so plus 5a. Both a's go away, so plus 2. All right, so the question is, can this factor to reduce out more? And it can. You would get, we come down here, a plus 2. Wait, will that one factor? I might be mistaken. That will not factor. So you are actually done. That's as far as you could go. So that's your answer. So I was wrong about factoring. That will not factor. Okay? All right. All right, number 5. This one's tricky. You've got X, Y, and Z. So it looks funky or it looks tricky. But really, because you've got an X, a Y, and a Z, X, Y, Z would be your least common factor. So when I multiply by this, I get 1xyz over xy plus 2xyz over yz plus 3xyz over xz. Okay? And then the denominator, that one's actually easier. 2x plus 3y plus z, because the xyz, well, I'll write it, times xyz, but think about it. You've already got xyz in the bottom. Don't distribute that, just that reduces out. Okay? All right. So the y's and the x's go away here. So I'm left with z. The y and the z go away. So I'm left with 2x. The x and the z go away or reduce out. So you're left with 3y. Now here's the crazy part about this. These are actually like terms because of all these different operations or the different properties that you've learned over the years. Commutative property says the number, like this z could go back here. You could say plus z. We've used it this year, but not called it that. Well, look, these are exactly the same. So you just get 1 over 1 or just 1. So the answer to that question after all that work is yes, 1. And the answer is
the media center with your computer. Mr. Holloway, please report to the
All
media
right.
center with your computer.
Now number 6,
Mr. Brown, please report to the media center with your computer. Mr. Brown, to the media center with your computer.
number 6, I'm going to hold off on. If you are and if you're in honors, I am going to do that one. Or if you're not and you'd like me to show you, I'll be glad to show you. But I'm going to hold off and stop the video now because I'm trying to keep it to a reasonable amount of time. All right, so you should have these notes written in your notebook when you come in tomorrow so that I can check you off and give you full credit. All right, have a good day.